Hey, chemistry. What we've done up to this point in time, if we've looked at one molecule, kind of like this one cat, and we've said, hey, that mass has how many moles in it? And we've only ever looked at the one compound. So we can go from grams of that one compound into moles of that one compound, or from the moles of that one compound to grams of that one compound. But that's only so helpful. In fact, it lets us count the number of molecules we have. But that only has a use if it allows us to predict what happens next. So in these chemical reactions, we want to think about the products. If we're going to manufacture medication and antivirals and treatments, what we really need to do is focus on how does that one molecule that we can know about, from grams, moles, and moles to grams, convert into the one molecule that we want to make or that we want to know about. And this is what I'm going to call molecule to molecule conversion. It's the heart of stoichiometry, and it's the most important part of stoichiometry. It's the part where we're now going to branch out our thinking. And instead of being stuck on one molecule, we're going to, So here are the rules. When you do this conversion, both the molecules, the molecule you're starting with and the molecule you want to end with, both of those molecules need to be in the unit of moles. We balanced the chemical equations to make sure we weren't magically creating atoms. We cannot magically create mass. So if we're going to convert from one molecule to another, we have to conserve the atoms and the mass of those atoms. As such, we can only rearrange them. So the number, the count of those atoms has to stay the same. And that's what moles is doing. It's counting our atoms. It's counting our molecules. So you have to be in moles. And when you do the conversion factor, and remember, that conversion factor is what we put inside the parentheses, right? So we're still going to be following the same pattern. We're going to take what we're given, okay? And we're going to multiply it by a conversion factor so that the math produces our desired unit, right? Now again, up until this point, we've talked about grams and moles and moles and grams, okay? Now we know that that conversion factor is very important because we can go from grams to moles or from moles to grams. You can go either way across that bridge. You just have to make sure that what you're given, the given unit, goes in the bottom. I'm going to try to write with my finger. We'll see how that goes. And the desired unit goes on the top. All right. So that's not written completely legibly, but we're going to go with it anyways because we're following that same system that we've always been following. And what you'll notice is we're really trying to go out of this island of A. I call it the island of A because if I just look at molecule A, I know how to do all the conversions that are shown. I know how to go from atoms or molecules that count right here to moles by using Avogadro's number. I know how to go from moles to mass and mass to moles by using the molar mass. But none of that gets me out of that one molecule. That's the island of molecule A. And sometimes you want to move over to molecule B. Sometimes you're like, hey, those reactants are great, but those reactants don't cure my medical disease or illness. So I have to get to the product that is the medicine. So I need to switch from moles of A to moles of B. You're noticing the only way to get from island of molecule A to island of molecule B is, in fact, to use the mole to mole ratio that's set up by the balanced chemical equation. Okay? So if we're going to go from moles of A to moles of B, we're going to be using the coefficient in front of the A and the coefficient in front of the B. And those two numbers, the little a and the little b, that's going to be what allows us to convert from molecule A to molecule B. Right? Still using the same format. What we're given equals what we're desiring divided by what we're given. That allows us to convert into desired units. So let's say we're trying to figure out, right, how much B we can produce. So if I want to know how much B I can produce, my desired is moles of B. So that means my ratio is going to be moles of B over moles of A. Okay. And if I multiply that conversion factor by moles of A, my moles of A will cancel and I'll end up in moles of B. So if I put moles of B over moles of A, or in other words, little b over little a, that allows me to switch from molecule A to molecule B. So this is great in concept. Let's go ahead and try. So we have potassium chloride. Now the question is, how many grams of that potassium chloride, just to emphasize the point, that's potassium chloride right there, are going to be produced if 35 grams of potassium chlorate, right there, right, decomposes. So what you can see in this problem, and what I'm hoping you can really quickly analyze, is that you're being asked to take 35 grams of potassium chlorite and go to grams of potassium. So you're switching between the potassium chlorate and the potassium chloride. The only way you can do that is somewhere in the middle. You have to have a conversion that has moles, because remember, you always have to be in moles, of KClO3 underneath moles of KCl. So in there somewhere has to be that conversion factor, because the only way to switch molecules is to use the mole-to-mole ratio. And you'll notice in this case, our mole-to-mole ratio is going to be 2 and 2, which is a really nice fact, because that's 2 divided by 2 is 1, so it's, mathematically simple, but conceptually still a solid problem to address. But we're not given moles of potassium chlorate. We're given grams of potassium chlorate. See? Right there. It's grams of potassium chlorate. Well, luckily for us, we know how to go from grams to moles and moles to grams. Okay? Because we know, if we're thinking about that roadmap on the last slide, if we're switching between them, we're going to use the molar mass. So let's use the molar mass. So I plug in the molar mass, which is 122.55 grams of potassium chloride. Quick reminder, if you're going to find potassium chloride, it's going to be 1 potassium, 1 chloride, and 3 times the oxygens. So make sure you can get that right, that correct number of 122. You'll notice the grams go on the bottom so we can get cancellations. And that leaves us with moles of potassium chlorate on the top, which is what we're going for. We want to be in moles of potassium chlorate so we can convert into potassium chloride. So let's plug in that ratio. Right? You'll notice my moles of potassium chlorate are on the bottom. My moles of potassium chloride are on the top, because that's what I'm being asked to convert between. I'm emphasizing that we're in the unit of moles, because moles is the only way you can switch molecules. If you're going to have a different molecule in the bottom and the top, you have to be in the unit of moles. And then you'll notice the other thing is we're using 2, right, which is this 2 right here. I know that because I'm looking at potassium chloride. So if I'm looking at potassium chloride, I take the coefficient from potassium chloride. And I'm using the 2 of the potassium chlorate, which just happens to be this, like, the same number. Coincidentally, that's what the balance reaction told us. So now I've gone from grams of potassium chlorate use the molar mass to put myself into moles of potassium chlorate, and now I've used the balanced chemical equation to allow me to do a mole bridge and convert from moles of one compound to moles of the other compound. But the question's asking for grams. So now I need to do molar mass of potassium chloride. So now if I simply do the molar mass of the potassium chloride, I'll be able to convert my moles of potassium chloride into grams of potassium chloride, and there's my answer. And that's how stoichiometry works. Setup of conversion factors. So hopefully this is helpful. Please jump on and ask me questions. I'm here for you. I'm here to help. Anything you need, let me help. So thank you for paying attention. Shoot me emails, shoot me questions, and I hope that this video has been helpful.